Hi, I'm George and welcome to part 40 of the Horizon series. Now this week we're going to have a look at the parachute deployment mechanisms for the booster as well as the camera pod that's on there. We're going to do some electronics flight testing, and finally we'll also have a look at the upgrades we made to the sustainer deployment mechanism. So let's get started. The deployment mechanisms for the booster are based on the prototype we did back in part 33 of the series. So if you would like to see how that design works, please see the link in the description. Right, time to make some real flight hardware. First we're going to make up 3 nose cones for each of the booster segments. The construction technique is very similar to what we've done in the past. The mold is just 3D printed and then covered with a couple of party balloons. The nose cone itself is made from fiberglass. We are making these nose cones a little stronger than normal, as they will be exposed to the second stage water jet as the rocket stages. We'll do some tests on this a little later on in the video. The balloons make it very easy to demold the nose cones. And then, after we let them cure, we have a set of 3 pretty rough nose cones. When the nose cones are trimmed and sanded, we can attach the coupler rings we made in an earlier episode. These are made from carbon fibre so that they are a little stronger. They're attached to the nose cone with 24-hour epoxy. The next step is to attach the payload bay tubes we made earlier. Eventually a couple of these will look like this prototype from last year. The tubes are attached with a coupler ring glued to the top of the pressure chamber. To make the job easier, we put the pressure chamber on its end on the stairs so that we have easy access to the top of it. Here we're just tacking on the ring with beads of epoxy. To ensure that the coupler ring is correctly aligned, we're using the payload bay tube and 3 angled brackets as an alignment jig. We leave this to cure overnight. The next day we can remove the jig, leaving the ring attached. And here are all the 3 pressure chambers with their rings tacked on. Now this ring needs to be really well attached so that the lateral forces coming from the parachute deployment or the staging event don't cause the whole payload bay to be ripped off. To get a strong bond between the ring and the pressure chamber, we pour quite a bit of epoxy to fill in that transition. Lastly, we use a flame to pop the little bubbles that have come up from the epoxy. While that all cures, we're going to switch gears a little and have a look at the deployment electronics. Now initially we wanted to use the Stratologger CF altimeters from Perfect Flight, as we've had good experience with them, but they sell really quickly when they're available and we weren't able to get any in the end. So we decided to go with the Rocket Flight Computer, which Dan was kind enough to send us. Now we've used these previously, and one of the nice features is that it already has servo motor control built in. For a redundant backup for the other deployment mechanism, we decided to go with the Eggtimer Quantum Flight Computer. Although we hadn't used these before, they were well recommended. We did have to solder these ourselves, so that meant we would need to do a bit of testing to make sure that we, and I really mean me, didn't stuff something up. The instructions were very detailed though, and it only took about an hour to solder it all up. Before fitting the flight computers in the booster itself, we wanted to test them in actual flight to see how well they detect apogee and activate the deployment servo. We did this by fitting the flight computer to the side of one of our regular water rockets. We also used the actual servo motor and battery we were going to be using on the booster itself so we could test everything fully integrated. We placed a small camera above the servo motor so it could record when the servo motor actually moved in relation to where the rocket was in flight. The flight computer here is not being used for actual parachute deployment. That's handled by a completely separate timer set to deploy past Apogee so that we can see what the flight computer does through Apogee. Here is that first flight.
3, 2, 1, go!
And here's the onboard footage. When we did a quick video review in the field, all looked good. But it wasn't until we got home and we had a proper look at the video that we noticed that the servo motor activated just after boost. Now, we've flown this flight computer successfully previously, so we weren't sure exactly what had happened. Deploying the parachute during boost would be suboptimal. So not a great start, but it shows why testing every subsystem is so important. Next up was the Quantum flight computer. This was again attached to the side of the rocket to fly along as a payload. Although the Quantum does have servo output, our servo timer has more configuration options, and so it was much easier to just trigger our timer from one of the Quantum's pyro channels. And here's the second flight with the Quantum.
3, 2, 1, go!
This was our very first flight with it. Here is the onboard view. As you can see, it activated the servo right at Apogee. Unfortunately, the parachute got tangled when it was ejected from the deployment mechanism and didn't come out until about a meter above ground. Fortunately, the flight computer wasn't damaged. It was one of the reasons why it was being tested on the side of the rocket rather than on the nose cone. So I just wanted to jump in here and say that the Quantum flight computer had nothing to do with the crash. The Quantum flight computer performed as well as expected, which is really good. Now for the rocket flight computer, that's the first one that deployed the servo motor too early. It has open source software, so we can potentially go in and try and analyze what happened and even potentially fix it, but that would require another whole test campaign, and we simply just don't have the time for that before the big launch. Luckily, we had bought a second Quantum flight computer with the first one, and so we're going to replace the rocket flight computer with the Quantum one for the second parachute pod. It won't be tested in flight, but we certainly tested it on the ground and it seems to be working just as well. Now, when we finish this project, we'll go back and have a look at the rocket flight software and see if we can fix it. I really like the flight computer. We've used it in the past successfully, but it was just too high a risk to take. So that's why we've switched over to the Quantum one. But anyway, let's get back into the build. To mount the electronics for the deployment mechanisms, we 3D printed these frames. At the top, we have a couple of different battery mounts, depending on the batteries we choose. These are easily replaceable. Now we have to mount these on top of the pressure chambers. For this design, we went with a single set of screws that mount both the payload bay frame and the payload bay tube to the top of the pressure chamber. In previous designs, we would often have a set of screws that attaches the 3D printed frame to the tube, and then a second set to attach it to the pressure chamber. The same would normally be done to the nose cone end of the payload bay tube. With the 3 pressure chambers, this saves us having to add around 50 screws to the payload bays. It also makes the design a little more compact. Here we're using a torch so that we can see where the holes are, so we can drill the matching holes. Now it's time to measure the length that the tube needs to be. And then the tube gets cut to the right length. When that's done, we can drill out the forward set of holes into the nose cone. Normally you wouldn't need quite so many screws to hold the nose cone on, but because it will be blasted by the second stage exhaust water jet, we really need to make sure these are secure. Instead of threaded inserts, we use regular hex nuts, and then use a soldering iron to melt the PLA around them so they don't fall out. It looks a little messy, but it works quite well. Now we have to cut a hole in the tube for the parachute door. Again, a torch is helpful to figure out where the edges are. A Dremel is an easy choice to cut this section. The secret is to take a few lighter, faster cuts rather than a slow, deep cut, which tends to melt the epoxy and gum up the cutting disc. So we had the brilliant idea to use a power washer to see how the top of the payload bay tubes would handle the blast of water coming from the second stage as it flew out of the booster. This passed with flying colours until we did the calculations, which said that the actual jet from the Sustainer would be about 40 times more powerful. So we'll see how that really goes. Okay, enough with the shenanigans. Now let's mount the electronics on the 3D printed frames. And here are the details. So here we have the fully assembled deployment mechanism. So over here we've got the quantum flight computer, and above that we've got the servo timer that's connected to the drogue channel of the flight computer. At the top we've got two sets of batteries. One set powers the servo motor and the servo timer, and the other set powers the quantum flight computer. And on this side we've got the actual servo motor that deploys the parachute, and a power switch so we can turn everything on. And over here is the ejection plate. The ejection plate just uses a couple of rubber bands that allows it to have maximum range of movement. Okay, so let's turn it on. So the servo timer is armed now. And one thing we can do with the quantum flight computer, it's actually get a Wi-Fi connection, so we can access the flight computer through a phone. So let's do that now. So we can select drogue channel. We got to enter in the code 376767, and starts the countdown. So now we should be able to see when it counts down to 0, you should see the servo motor move. There we go, that's a successful test. Now I didn't have time to film this when I was making it, but the actual hinge for the door is just made out of some cotton cloth that's been epoxied both to the door and to the payload bay tube. Now one of the tricky things was to get that epoxy as close to the edge as possible on both sides without actually getting any of it on the bendy part of it. So that was a little bit tricky, but that turned out pretty good. And very easily open, and it's very strong. That's not going anywhere. So that's how we solved the hinge problem. We've added this aero cover over the top of the door so that any airflow over the rocket wouldn't try and open the door itself. So that's just 3D printed and just sits over the top of the door. There's a gap at the bottom of the parachute door where the shock cord can emerge. The parachute door itself is actually held down by twin rubber bands that hook over the horn of the servo motor that's just in here. And then here you can see when we release the servo motor, we'll just do it mechanically. That's how it pops out. And the total weight of the entire deployment mechanism is about 530 grams without the parachute. And then with the parachute and shock cord, that brings it to about 663 grams. So now let's have a look at the camera pod for the booster. So over here we've got an old Hero GoPro Hero 3. This is actually the first time we've flown a GoPro. That's looking out to the side, and over here we've got an 808 camera that's pointing pretty much down past the rocket, so we can see just the edge of the rocket. Now, because we wanted it to sit on the pad for quite a while, the battery inside of these cameras aren't all that good. They'll last maybe half an hour or so. So what we've done is we've rewired the internal battery, and we have an external battery back here, a much bigger LiPo, and that'll give it at least an hour worth of footage. We've got a big enough SD card in there, so that's not an issue. Now, same problem for the GoPro, because this one is fairly old. We've had that one for quite a few years. The batteries don't last as long anymore, so we'll have a look at that battery in a second. But anyway, there is an aero cover for this module that just fits over it like that. And we can screw it down. Okay, so let's have a look at the frame that it fits in. So this frame is very similar to the deployment mechanism frames. The difference being is there's a couple of big batteries used for powering the GoPro, and that, again, that should give it at least an hour worth of footage. Because the GoPro requires, this old GoPro requires to be powered externally by USB, so we've got a USB cable which requires 5 volts. Of course, this doesn't give us 5 volts, so we've got a voltage converter down here that turns the 8.4 volts down into 5. That then powers the GoPro that's inside of here, and then we've got a power switch over here. Okay, so let's put the whole thing inside of the payload bay tube. We'll just secure it with one screw down here, just so it doesn't go away. And now we would go in and plug the GoPro, but this is what we're able to do out in the field. And then that secures with another 3 screws into the actual payload bay. And then we can put the nose cone on top. And then we would go and secure that. So that's now ready for flight. And the whole camera pod weighs 664 grams. And for completeness, here are the 3 payload bays. Next, let's have a look at the new sustainer deployment mechanism. To see how the original one was built and for details of how it works, please see part 12 of this series. So here's the upgraded sustainer nose cone. Maybe let's start over here. We've got a GPS that's been added now. We've got a servo timer to control the servo that's buried deep inside there. On the other side, we have a stratologger altimeter. So this is what detects apogee and records the flight. We also have an HD camera right here. There's a servo motor just below the camera. And altogether, there are 6 batteries. So there's one here, another one on the side here. Then we've got 2 down here. And then there's 2 sandwiched right between the 2 boards to provide power to everything. So we can turn it on. And the servo timer is now armed, and the tabs, the deployment tabs, are locked. So now it's waiting for launch and then to detect apogee before it'll release these, as we've seen before. So that's the new upgraded nose cone. Let's turn that off. And then we can put the nose cone, this is the existing nose cone that we've had, over the top like this. A little tricky to get on. There we go. And that's the only thing that pokes out of the nose cone. So that's all for this week. In the next episode, we're going to have a look at how the fins are made and how they get attached to the rest of the booster. Anyway, thanks for watching, and we'll see you next time.
Launching in 5, 4, 3, 2, 1, go! There's no wind.
Wonderful.
Yep. So it's water propellant.
Yes.